we gotta start this whole story about sine function in graphs and key features, everything based on this unit circle again. As I emphasized during last instruction, that we need to know all the essential information from this unit circle. And as you see, all the critical points all over the circle, and we need to know the position of the angles, each angles in degrees and radians. And each critical point, each critical position that we need to know how to, at least how to construction, or at least you have to remember the coordinates as the exact values of sines and cosines all through that circle, right? And there's some additional information, sines and everything, but we will get to that part later. But at least I need you guys to see the angles and the exact values, okay? To remind you guys of this, because if we go with the angle 30 degree or the radian equivalency pi over 6, then now the way that we constructed the exact value as a coordinate is the first coordinate, radical 3 over 2, is horizontal, because the hypotenuse slash radius is 1, then the coordinate out of this inscribed right triangle could be just adjacent leg length, right? So this is horizontal, and this is the angle of the cosine value. Then the vertical coordinate and vertical exact value is involving with the opposite leg of this inscribed right triangle of the angle, right, of these angle theta. Then this one is obviously involving what? Sine of the angle. And it's applicable all over the exact value. So now we're utilizing the fact the horizontal axis will go by the angle measure. So again, we'll go by angle measure. So it's gonna be 0, pi over 6, pi over 4, pi over 3, pi over 2, and so on, all the way up to 2 pi again. The horizontal axis will be labeled with the angles. And the vertical axis will be labeled with all these sine values. So sine theta. Then we can plot them as usual when we construct a function graph. Then that's how we get the sine curve or sine wave in sine graph. Okay. Then I will show you how you can do step by step on this slide. And when I have the actual in-person class and we have more time, so I just give some opportunities for everybody, use just mini whiteboard with markers, and they can just figure this out while they're discussing with their partners or group members. But with the circumstances, and I would just give you guys some steps directly from here. So as I said before, as usual, we need 2 axes. Then I will start from horizontal axis here. And I will need vertical axis here. Okay, then I intentionally put the vertical axis not in the middle of that horizontal axis, but it's kind of like a tilted to the left because I want to emphasize the one full period of the sine graph, right? Okay, so now let's start from 0. And this horizontal axis, where we can call as x, and this will be angles. And since we are putting more weight on radian measures, and then let's go with the radian measures, okay? And we can just go all the way here. So 0, and we can utilize the quadrant angles, pi over 2 and pi, and 3 pi over 2, and 2 pi again. So then simply we can have some even space dividing here. So it's like about half of here is supposed to be pi, right? And then half of pi will be here, and then it's going to be labeled with pi over 2. And if I go exact same distance from pi, and then it's about here, it can be labeled 2 pi. Then in between pi and 2 pi, it could be labeled as 3 pi over 2. Okay? Then, now, we are constructing what function? Sine function graph. So, we follow the vertical coordinates out of this unit circle, right? Then, when angle value is 0, so I forgot to label this one. Why? When angle value is 0, right here, and the sine value is also 0. So it's gonna be 0, 0, right? Then when angle value is pi over 2, the sine value is what? 1. So let's say we can go here, and then this will be labeled 1. So this is pi over 2 comma 1. Then when we hit pi here, the sine value is not -1, 0. So it's going to be pi comma 0 here. Then pi over 2, the sine value, which is the second vertical coordinate, is -1. So it's going to be down here, -1. Oh, what am I doing? 3 pi over 2, and then it's going to be -1. Then once we hit 2 pi again, and then this becomes 0 again, right here. Then we can go by all the critical points between the quadrant angle. So now when I hit 30 degrees, so it's going to be about here. So 0 to pi over 2 is technically 90, but pi over 6 is 30. So I can just have even 3 pieces, and then it's going to go up to 1/2, right? Then pi over 4 means in between 0 and 90, it's in the middle, so it's pretty much in here. And if you get the approximation of radical 2 over 2, it's just 1.414 divided by 2, right? And then it's a little bit higher than 1/2. It's 0.7 about, right? Then it's going to be about here. Then when we go 60, and then you will see it's about a little bit higher. So then if you just go through all the coordinates and then get the approximate, and then you just plot, and then you will have this track. Then, as usual we do, we connect those plots and we can have this smooth continuous curve there. Then, as you see, it's gonna keep repeating over and over, and we will expect it's gonna have same, right, to the right. And I will put the arrow there. And to the left, it's gonna continue that way as well. So this is how you can utilize the unit circle in order to construct sine function. Then if there's no restriction over the domain, it will repeat every time. So just remember you put the arrow at the end, okay? Okay, any question? So later when you get to watch this recorded video, and I strongly recommend you guys to take out a paper and pencil and your reference with the unit circle, and it's gonna be fun. So just practice it, okay? So let me save this image there. Okay, then let's see a little bit more cleaner image there. So as you see, this is a sine function graph here, and starts from 0, 0, and then pi over 2, comma 1, and pi, comma 0, 3 pi over 2, comma -1, and 2 pi 0 again. And as I said before, it has the arrow at the end of both sides, and that indicates it's gonna repeat everything. So then from here, as usual, every time we come up with the parent function. So this is simply the parent function graph of the sine function. So it can be written as an equation, and y equals sine of x. That's all, right? Then domain, -infinity to +infinity, everywhere in real number system. Range, very interestingly, it's never gonna go higher than 1. It's never gonna go lower than -1. Remember, it was from the unit circle. Unit circle is all trapped within the radius 1, right? So it's never gonna go out of the range between -1 and 1, and they are included as the maximum here and minimum here, right? Then also another key features for you guys to notice here is the zeros. Zeros are nothing but the solutions when you look at the function algebraic respect, and you will see them as solution. And if you see them in the graphical aspects, then yeah, that's x-intercept. So zeros, solution, or x-intercept are here, 0 and pi and 2 pi. If we limit the interval between 0 to 2 pi, why do we specifically limit the interval between 0 to 2 pi? Because that's meaningful, because that's the one segment that appears repeatedly over and over again. That's the one pattern, right? Okay, so any questions so far? All right. Then let's take a look at any key features from sine function graph, okay? So what key features can we predict? We already talked about 3 different key features from this type of repeating, the reoccurring situation, it was 8.1, right? Okay. First, amplitude. Amplitude is how far, so it's technically the vertically maximum or minimum, how far the maximum or minimum from the vertical midpoint. So if this is a midline here, we measured from the vertical mid position and the distance from the midpoint, mid position, and either maximum or minimum, and it indicates how far vertically dilated. Okay, so that's amplitude. And if you remember from the 8.1, and this amplitude is usually notated with the letter A, and also it should be absolute value there, right? Because we only care about the distance from the mid position to either maximum or minimum, right? So the distance that doesn't have the direction, right? And we will notate everything with absolute value. Okay, so that's amplitude. And what could come next? Period. So for sine function, and if we just, it doesn't matter. You can start from here and then it goes up to, so let's say it extends like this. And you can consider from this position and all the way to another position, right? And then you can even start from here and then it's gonna just go hit and then like it's out of the range. But like at the end of this repetition, it doesn't matter, but it might be convenient if we go from the starting point and then it shows perfect one circular motion and we notate where it ends, then horizontal length of one perfect pattern of repeating, then that's gonna be define the period of any transformed sine function. So the horizontal length of the one repetition is called period, right? Okay, so what's left? And midline. So midline is nothing but the mid position of this repeating waves, and it's a vertical midpoint, right? So for example, this given parent function, midline is always where? Y equals 0, because there's no translation vertically happen. Okay, so I need you guys to remember, we always observe how amplitude, period, and midline changes, right? Then that indicates how the sine function given has been transformed from the parent function and into that equation, okay? So let's take a look at the structure of the transformed equation. So now, typically we will see the structure of sine with all kinds of possible transformation included. We'll take this structure. And as you notice, all the features that indicates a transformation around that sine function equation is working very similar to all other kinds of function equation as well. But within section 8.4, we will focus more on A and B value. And C and D are gonna be explained later section, I think it's 8.6. But these are involving, as you already noticed, it's just like with your gut feeling, Yeah, they're related with the translation. But today, for sine function, kind of newer concept of the transformation is the amplitude and period. And these two values around the transformed sine function equation were directly related to amplitude change and period change. So amplitude change is the value that plays in front of the whole function equation. And the period change involved with the value that is positioned in front of what? The input x. But sometimes you see this b value placed outside of parentheses or inside of parentheses. Then that's only the difference where you factor that b value out of the two values inside of parentheses or not. So either way, you can distribute the b value if that b value is placed outside of the parentheses, or it was already altogether inside of it, and then you can just utilize it as it is. The only difference is that, right? Then let's focus on value A and B, how each value appeared on transformed equation of the sine function affect the graph of the sine function here, okay? Okay. Again, A is amplitude, and then the B value in front of X was affecting the period here, okay? They're very similar. When we had, for example, y equals 2x squared, right? Then these two in front of the quadratic function involving vertical stretch or compression. When a value is greater than 1, any whole number or fraction or a mixed number, then it vertically stretches the graph. So then, if you imagine your original sine graph vertically stretched, then of course the amplitude original, it goes up to 1, it goes down to -1 will be stretched longer, right? So it could go up to 2 and -2, or it could go 3.5 up and up to -3.5 down, right? So with value A greater than 1, and you know vertical stretch happens, and that's gonna affect the amplitude, right? Then if the A value in front of it is in between 0 and 1, and that's gonna shrink vertically, shrink the sine wave vertically, so it's gonna be shorter. So if A is half, then it's not gonna go up to 1, it's gonna go up to half, 0.5, and it's gonna go down to -0.5. So it's shrinking into the half, right? Then what if A is negative? We usually, this leading coefficient A affects the graph with negative value. How? What was it? We're remembering y equals x squared and y equals -x squared. This negative value in front of the function equation involving reflection over x-axis, right? So then if A is less than 0, then probably involving with reflection, okay? Then let's move on B here. So specifically, the top one includes C and D, but since within this section 8.4, we are only focusing on A and B, and this is just only include A and B. And notice the B value goes directly with the X inside of the parentheses altogether. Then you recognize B value, and this B value indicates just numbers of full cycles within 2 pi. So then if B is 2, then that means within 2 pi, you will see 2 repetition of that sine graph. So that means, let's say this is a 0 and then this is 2 pi here, right? Then original sine will be in the middle as a pi. As you see previously, 1 repetition should follow this, right? But if you have y equals sine, instead of just x, if you have what? 2x. That means it has to have 2 repetition within 2 pi. 2 repetition within 2 pi. That means I have to have 1 repetition within first pi and another repetition within the second pi, so that this green one is graph of sine of 2x. So then what can be simple algebraic calculation for us to get the period directly? So you use this B value directly from the equation. You recognize it because this is number of repetition, number of cycles within 2 pi, and the 2 pi will be divided by the B value directly here, B value directly here. So then here, so now in this case, 2 is the B value. Then 2 pi is always on top, and divide that by what? 2, so B is here, and then it's canceled. And then 1 period length is pi, then look, 1 repetition was squeezed in pi. So now this is 1 period of the newly transformed equation. So now the B value involved with horizontal stretch or compression. So in this case, we observed how it works with compression, right? And then these two things are very good to remember. And this is algebraic way of figuring the period after the transformation, okay? So it is very new and it might be really big concepts for you guys just digest right away. So make sure you watch both of the videos repeatedly until you have the understanding here, okay? Then, since we have almost time, then I will move on to the one example that I prepared, and that's gonna be the last one, okay? Then, let's see. We have sine function equation. It goes y equals 3 sine of 4x. So now we remember the 3 involves amplitude because it's a vertical stretch. Then 4 is the B value, and then it's gonna involve period. And then now B is what? 4. and amplitude, and then what? A is 3. And again, it's amplitude, and then we're gonna just have the absolute value there, right? Then this means what? Vertical stretch 3 times, right? Then this B being 4 as a value, that means we will see 4 even repetition within 2 pi, right? So then the denominator, numerator is always 2 pi. And then now we put 4 under there. Then this is pi over 2 when it gets reduced. That means new period is pi over 2. That means we horizontally squeeze the original sine function within what? Pi over 2. So from parent function, so let's start from here. So let's draw parent function of sine, x, y. Sine starts from what coordinate? 0, 0. And then it always goes pi and 2 pi. And then I can go half of each, pi over 2, 3 pi over 2. Then it was 1, negative 1. And then it was originally like this. And of course, we're supposed to extend both sides with arrow. So this was sine parent function graph. Then now, I guess it's either way, but let's take care of the period first. So then it doesn't go all the way to pi to have the 1 repetition, but it has to be done by pi over 2. So now I know the new repetition should be ends in pi over 2. Then we expect it's gonna go up and down and then hit that end point there, but also we know this has to be vertically stretched 3 times. So it's not going 1 and negative 1, but it has to be 2, 3, and then negative 1, negative 2, negative 3. So it was supposed to go up and down, and it fits the new period pi over 2. That means I will have another repetition within the next pi over 2, and I will have another repetition within the next pi over 2. I will have another repetition within the next pi over 2, and then I can just simply put extension with arrow and I'm done. So do you want to see the cleaner image? Yeah, I prepared here. So now as you can see, from 0, the first period within 2 pi, then it goes up to 3, and then it goes down to negative 3, negative 3, negative 3, and then it repeats 1 repetition perfectly. And then it goes the other side, same repetition, the other side, and same repetition all the way.